Good morning, one and all. So let us start today's class. So in the last class, we have seen what is the probability mass function of a random variable. Probability mass functions of a random variables. So we have solved one problem. So let us go to the example 2.6. Calculate the PMF of a random variable x, that is maximum roll in a two independent rolls of a fair four-sided die. So what they are asking is, so a 4d4 die is rolled 2 times and we have to find out the PMF of x. Random variable is x. What is defined as maximum roll? X is the maximum of 2 rolls. So for that random variable, this is a random variable. So we have to find out the probability mass function of that particular random variable. So let us go to this is the sample space of the experiment. So there are 16 possible outcomes. 1 1, 1 2, 1 3, 1 4, 2 1, this is 2 1, 2 2, 2 3, 2 4, 3 1, 3 2, 3 3, 3 4, so on so on. So what is the x is a maximum, right? What are the possible values of x? Maximum can be 1, it can be 2, it can be 3, and it can be 4 finally. Correct? Now, so what a probability that x equal to 1? So we have to find out probability mass function, right? So small x also takes on these 4 values: 1, 2, 3, 4. Okay. So first of all, we have to find out PMF, Px of x. What is the definition? Probability that x equal to small x. Now if I ask you, what is the probability that small x equal to 1, which means probability that capital X equal to 1, which means what is the capital X defined as? Let me write here. So the capital X is defined as maximum roll, maximum of 2 roll. Okay. Now, so I'm asking what is the probability that maximum roll is 1. Now what are those events? 1, 1 is the only possibility when we get maximum of 2 rolls is 1. Correct? Now what is the probability now? So I told you already, all are equiprobable, but this event has got only one element, 1 over 16. What is 16? Total number of elements in the sample space. So this probability is 1 by 16. So simply you can say Px of 1 equal to 1 by 16. Okay. Next, what is Px of 2? Which means probability that capital X is equal to 2, which means probability that the maximum of 2 rolls is 2. Now how many such events are possible? 1, 2, next 2, 1, next 2, 2. Any other thing? Any other possibilities? So these are possibilities. How many are there? 3. Total 16. So 3 by 16 is the next PMF. So what is the probability of, PM of Px of 3? That is probability that capital X equal to 3. What do you mean by this? Probability that the maximum of 2 rolls is 3. How many such events are possible? How many are possible? 5 out of 16. So you just try to understand things very cleverly. Finally, so Px of 4 means what? Probability that capital X equal to 4, which means what is capital X? Random variable which is defined as, how it is defined? Random variable that is defined as maximum of 2 rolls. Now how many such events are possible? 7 out of 16. Okay. Now here, so you can simply write, so the probability mass function of this particular experiment of the random variable can be written like this. So you can draw the figure here. So this is what you can draw. This is x. Okay. Now, so what are the probabilities you got? 1 by 16. Next, 3 by 16. Next, 5 by 16. Next, 7 by 16. This is 1 by 16. This is 3 by 16. This is 5 by 16. This is 7 by 16. Correct? Now, so what is this probability? Sorry, I written reverse. This is 1. This is 2. This is 3. This is 4. This probability is 1 by 16. This probability is 3 by 16. This probability is 5 by 16. This is 7 by 16. Now this is Px of x. So this is what? PMF. If you add all the PMFs, what do you get? 1 by 16 plus 3 by 16 plus 5 by 16 plus 7 by 16. How much you get? How much you should get? So if I write summation over x small x, Px of x should be equal to how much? 1. Which means sum of all PMFs should be equal to 1. After all, PMFs are nothing but probabilities. So that's why sum of all probabilities equal to 1. In the same way, sum of all PMFs also should be equal to 1. Okay, it's very important. Now, so that is how we find out the probability mass function of the random variable in this way. Next, so this is a notation. We will use uppercase character to denote the random variable and lowercase character to denote the real numbers, such that the numerical value of a random variable. Also note that sum of all PMFs should be equal to 1. This is also very, very important. Okay. Now, so here let us see various types of random variables. Okay. So till now we have seen how to find out the probability mass function of a given random variable. Now let us see the various kinds of random variables that we encounter in this course. The first is the Bernoulli random variable. As I mentioned in the last class, Bernoulli trials. What are they? A trial which has got only two outputs or two possibilities. Example, tossing a coin, the possibilities are getting head or getting a tail. In the same way, conducting an experiment, the possibilities are you may succeed or you may get failure. So like that, so Bernoulli random variable can take only two values. What are they? 1 or 0, depending upon the outcome of whether outcome is head or tail. So if the outcome is head, so let me write something like that. So for understanding purpose, suppose we are conducting experiment. Let's assume that it is a tossing a coin experiment. So what are sample space? Getting a head or tail, isn't it? This is sample space. But so we have to define a random variable. So we call it as a Bernoulli random variable. So here what we do? We assign, so for head we assign 1, let us take. For tail we assign 0. For tail we assign 0. So that is how we use Bernoulli random variable. So always we think that, so if it is a fair coin, probability of getting head is same as tail is same as 1 by 2. If it is not fair coin, if it is a biased coin, so the probability of head is P, the probability of tail will be what? 1 minus P, that is also called as Q. Okay. Now, so what the probability that x equal to 1? X equal to 1 means what? Getting head. What the probability? P. So what the probability that x equal to 0? X equal to 0 means what? Getting a tail. Getting a tail means what a probability q or 1 minus p. So that is the probability mass function of the Bernoulli random variable. Now this is what the probability mass function of the Bernoulli random variable. If you add all these elements, what do you get? P plus 1 minus p equal to how much? 1. So that is satisfied. So please remember, if you add all the PMFs, the sum should be equal to 1. After all, PMF is a probability. So you know already sum of all probability should be always equal to 1. So please note this. This is a Bernoulli random variable PMF, probability mass function. Now this is how the Bernoulli random variable is defined. Okay. Here it need not be head or tail. It can be anything. It can be success. It can be failure. Okay. Depending upon the experiment, things will change. Okay. Now, so that is about Bernoulli random variable and its PMF. Now we'll study binomial random variable. Already we have seen binomial probabilities. What is that? What is, if you remember properly, Px of k. We have written like this. We have written Px of k. No, we did not write x, but at least P of k. What is that? Probability that k heads in a n-toss sequence. Okay. Now, so here that can be directly written as a random variable. Okay, let me read this properly. A biased coin is tossed. We always take biased coin n times. At each toss, the coin comes up with a head with the probability p, tail with probability 1 minus p, also called as q. Independent of prior tosses. Let x be the number of heads in the n toss sequence. What is the random variable? X. What is defined as number of heads? We refer x to a binomial random variable with the parameter n and p. The PMF of x consists of the binomial probabilities. Now it becomes a binomial probability, binomial random variable. So x is a binomial random variable called as a binomial random variable. It is defined as number of heads in the n-toss sequence. Okay. So we have solved one problem in the last class. So that can be modeled as a random variable. What kind of random variable? Binomial random variable. Okay. Now what is the PMF? You can directly write. We have used it so many times. What is that? This is a PMF. Just there is a difference in the notation, but everything is same. The concept is same. Okay. Now here we are writing k, not small x. Generally for PMFs, what is the notation I told you? Px of small x. Otherwise, sometimes we can use Px of k also, small k. Both are valid. Okay. So here we use small k instead of small x. So everything is same. Now as I told you already, sum of all PMFs should be equal to 1. Here also, if k varies from 0 to n, sum of all these PMFs should be equal to what? 1. Okay. Now, so let us go to the third variety of random variable, that is called geometric random variable. Now it is something different. Just read the statement properly. Suppose that we repeatedly and independently toss a biased coin. Okay, we are tossing a coin repeatedly and independently with the probability of head p. Okay, the geometric random variable is the number of tosses x, number of tosses needed for a head to come up for the first time. Okay, so how it is defined? Defined as number of tosses required for head to come up for the first time. What do you mean by this? What do you mean by this? So here this is geometrical random variable. So it simply says we are tossing a coin repeatedly. The probability of head is p. obviously the probability of tail will be q or 1 minus p. Now, so random variable is saying it is defined in such a way that x is nothing but number of tosses required, which means how many times we should toss so that head comes up for the first time. Okay, suppose if I say something like that, we got head in the 5th toss. Suppose x is nothing but 5, which means we got head in the 5th trial, 5th toss. In the 5th toss, which means what about remaining 4 tosses? You got tail. So in the first 4 tosses you got tail. So in the 5th toss you got head for the first time. Okay. Now what is that probability? What is the probability that x equal to 5? Let me take like this. Which means x equal to 5 means what? What is x? A random variable which is nothing but the number of tosses required for the head to turn up for the first time. So x equal to 5 means you got head in the 5th toss for the first time, which means in the first 4 tosses you got tail. Let me write here probability of tail equal to 1 minus p or equal to q. Now all are independent, so that's why what you can write. First you got tail at a probability q. Second also you got tail, probability q. Third also you got tail. Fourth also you got tail, but for the 5th time you got head. We stop here. Why? Because we got head for the first time in the 5th toss. What is the toss number? 5th toss. Which means we needed 5 tosses to get head for the first time. Okay. So what is the probability now? Q power 4 into p. What is Q power 4 means? In the first 4 tosses you got tail. In the 5th toss you got head for the first time. We stop here. So we conduct this experiment until we get a head for the first time. So we need to find out that probability. Suppose if I ask you, so what is the probability that x equal to 10, which means you got head in the 10th toss, which means in the first 9 tosses you got tail. What is that? Q power 9 into p. Okay. In generally, px of k, this is a PMF that is defined as probability that x equal to k. As I told you, we can also use small k instead of small x. Can you tell me what is that? What do you mean by this? You got head in the kth toss for the first time, which means in the previous k minus 1 tosses you got tail, means q power k minus 1 into p. Where k varies from? It starts from 1. It can go up to any value, but it starts from 1. Okay. So what may happen is you may get head in the first toss itself. If k equal to 1 means what? You got head in the first toss. So if k equal to 1, what is the probability? P. Because this becomes 1. Okay. So this is a PMF. Clear? So this is nothing but geometric random variable. Yeah. So this is how its PMF is defined. So you can also write this as q power. You can also this as q power k minus 1 into p. Here k varies from 1 to 2. Please remember, it goes up to infinity. We don't know when we get. Otherwise, we don't know at what toss we get the head for the first time. Okay. Now, yeah, this is what the generalized notation. More generally, we can interpret the geometric random variable in terms of repeated and independent trials until the first success. It may not be tossing a coin. You take any experiment. We use these kinds of random variable to find out how many trials are required until first time you get a success. Okay, it may be any experiment, but you try to understand the scenario. So don't think that always you get problems only in terms of tossing a coin or rolling a die. No. You try to understand the interpretation of the random variables. When we use these kind of random variables means what? we are doing experiment repeatedly and independently, how many such trials are required until you get the success for the first try. Okay, so you try to understand the scenario. Clear? Yeah, here also sum of all PMF should be equal to 1. Okay, so it should be true for any probability mass function. So sum of all PMFs should be equal to 1. Okay. Now, so this is the another variety of random variable, that is called geometric random variable. We have discussed how many random variables? Bernoulli. So let me briefly go to that Bernoulli random variable. So it has got only two possibilities. We say that x equal to 1 or 0 depending upon the head or tail, and this is the corresponding probability mass function. Now binomial random variable, already we have discussed extensively about this in the last class, so I don't think any further explanation is needed in this binomial random variable. Okay, right. Now this is geometric random variable. Okay, it's PMF, and now so this is the another variety of random variable, that is called Poisson random variable. It is called Poisson random variable. Okay, so it takes on non-negative integers. Okay, which means k equal to 0 to so on so on. PMF, I am directly writing the PMF. What is that? See, so it is somewhat different. Please try to remember this. Px of k equal to e power minus lambda into lambda power k by k factorial, where lambda is a positive parameter. I will tell you what is lambda later, but remember it is a positive parameter. So the entire probability mass function is defined by this lambda. Okay, so lambda is a very important parameter of the Poisson random variable. Okay, now so here everyone should remember this PMF directly. So what is the PMF? Px of k equal to probability that x equal to small k. Now here it happens to be e power minus lambda into lambda power k by k factorial. Okay. Now, so here let me go back to the something like this here. So what we got here is Px of k equal to e power minus lambda power k by k factorial, where k varies from 0 onwards, 1, 2, so on so on. Here, but we have something very important, summation over k or x. Px of k should be equal to 1. Sum of all PMFs should be equal to 1. How to solve this? So let me write here summation over k. What is P of x of k? This is what we have, e power minus lambda into lambda power k by k factorial. So but k varies from where? K varies from 0 to infinity, you can say. Now here e power lambda is independent of k. You can take that outside the summation. Is it okay? In this I will write e power minus lambda outside the summation, because that is independent of variable k. So you can simply write k varies from 0 to infinity lambda power k by k factorial. Correct? But so let us expand this. What will happen? So e power minus lambda, that is outside. So let me expand the summation. If k equal to 0, it is 1, plus if k equal to 1, lambda. If k equal to 2, lambda square by 2 factorial, that means 2, otherwise 2 factorial, let me write, plus k equal to 3, lambda cube by 3 factorial, plus so on, so on, so on. But what is this? Can you tell me what is this? What is that? This is nothing but e power lambda. Okay, you might have seen that expansion of e power x. What is that? 1 plus x square by 2 factorial plus x square by 2 factorial plus x cube by 3 factorial so on, so on. In the same way, it is e power lambda. So this is e power minus lambda, this is e power lambda. What is that? E power minus lambda into e power lambda will be equal to what? 1. So which means, so sum of all PMFs is equal to 1. This is equal to 1. Okay. So we'll solve some problems on this random variable. I have proved that, so sum of all its PMFs is equal to 1. Okay. Okay, right. So let us go to the problem here. Now, suppose the average number of accidents occurring monthly in a street is 2. Okay. Average means you just try to understand thing. So what is given in the question is lambda. Okay. So the probability that there will be at least one accident in this month. Okay. Now here, so we model this as a Poisson random variable. Otherwise, read the statement properly, question properly. Suppose the average number of accidents occurring monthly in a street is 2. The probability that there will be at least one accident in this month is estimated to be. Okay. Now, so what they're asking? On average, there will be 2 accidents in a month. So, which means they gave you lambda. Parameter is given to you. Lambda is 2. I will tell you about lambda later, but for time being, just assume that this is the average value of the Poisson distribution or Poisson random variable. Now, what they are asking? Probability that at least one accident. You know already. So probability of at least one can be written is 1 minus probability of none. No accident. Okay. Now, so this is the Poisson random variable with lambda given as 2. So what they are asking? Px of k. Okay. So what is k they are saying? At least 1. What is they are asking for? At least 1. Now we can also write that as 1 minus no accidents. This is a simple probability rule. Okay. So here we have to find out what is the probability that there are no accidents. Which means what is the k value? Equal to 0. So here, which implies we have to find out Px of 0. Later we have to subtract from 1. So let me find out Px of 0. Or let me write Px of k here first of all. That is e power minus lambda into lambda power k by k factorial. So what is Px of 0? K equal to 0. That is simply e power minus lambda. That equal to e power minus 2. E power minus 2. But, so what is the probability that at least one accidents? Probability of at least one is nothing but probability of no accidents. 1 minus probability of no accidents. Which means 1 minus Px of 0, which means which means 1 minus e power minus 2. Otherwise you can write 1 minus 1 by e square. So this is the final probability. Okay, you calculate what is this exactly later. Clear? Now, so here let me briefly discuss these random variables. There are Poisson random variable, geometric random variable, binomial random variable and Bernoulli random variable. Okay, you try to remember their corresponding probability mass functions. Okay, so we'll solve more problems in the assignments regarding this random variable or varieties of random variable. Okay, now so let us move on to functions of random variable. Till now we have seen only a random variable x. Now let us see functions of random variables. So y is a linear function of x, y equal to g of x, y equal to x plus b. We have two random variables now, y equal to ax plus b. X is a random variable, y is also a random variable. But y is a linear function of x. So that's why y equal to ax plus b. Here, so it can be non-linear function also. Suppose y can be log of x or y can be mod of x. Okay, so y is a non-linear function of x or y can be linear function of x. Either way is possible. Now please remember, if x is a random variable, then y is also a random variable. Okay, suppose if x is a random variable, then so ax plus b is also a random variable. Mod x is also a random variable. Log x is also a random variable. Log x is also random variable. Okay, if x is random variable, y is also a random variable. Now here the question is something like this. Let x and y are two discrete random variables with y equal to mod x. Now x and y are related. What is y? Equal to mod of x. This is a non-linear function. Okay, y equal to mod x. And probability mass function of x is defined as something like this. 0 otherwise. Next we have to find the probability mass function of y. Okay, so read the question properly. We proceed further. Now we are discussing functions of a random variable. Y is a function of x. What function? Non-linear function. Now in the question they gave us its PMF. PMF of x is given to us. We have to find out what? PMF of y. Okay. So in these functions of random variable, generally what happens is we will be given the PM of x. Probability mass function of x will be given to us. We have to find out what is the probability mass function of y. But what is y? Y is a function of x. It can be linear or non-linear. Okay. Now, so what will you do? How to solve this? Okay, so let me write here capital Y equal to capital X. Obviously, we will write small y equal to small x. Okay, so please remember what is small y, small x? These are the small y is what? Possible value of capital X. Capital Y. In the same way, what is small x? Possible values of capital X. Okay. Now, here they gave us Pm of x, random variable x. How it is defined? Px of small x equal to 1 by 9. 1 by 9. If x is an integer in the range of, if x is an integer belongs to -4 to 4, which means only integers from -4 to 4 means -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, 0 otherwise. So it is given in the problem. They are asking what is the probability mass function of y. But we know capital Y equal to mod of capital X, which means small y equal to mod of small x. But so small x can take from what values? It is defined over integer values of range -4 to +4. Suppose if small x equal to 0, implies y is also equal to 0, because mod of 0 is 0 only. Okay, then so here then what will happen? Py of 0 equal to Px of 0. What is Px of 0? What is Px of 0? It is 1 by 9 from -4 to +4, which means, so when x equal to 0, its value is how much? 1 by 9. So that is simply 1 over 9. Now, if x equal to 1, y equal to 1, x equal to -1, then y is also equal to 1, because what is y? What is y? Mod of x. So that's why now here for y equal to 1 we have two possibilities. If y equal to 1 means x equal to 1 as well as -1. So that's why we write Py of 1 equal to, we have two possibilities for x, Px of 1 plus Px of -1. So what is Px of 1? 1 by 9. -1 also 1 by 9. Total 2 by 9. Now, if x equal to 2 and -2, then y equal to what? 2. Which means for y equal to 2, we have two possibilities of x. What are they? 2 and -2. So that's why Py of 2 equal to Px of 2 plus Px of -2, which means again 2 by 9. In the same way, you can also write, what do you write? You can also write, so Py of 3 equal to Px of 3 plus Px of -3, that equal to again 2 by 9. Py of 4 equal to Px of 4 plus Px of -4, that is also equal to 2 by 9. Here y can never be negative. Why? Because y equal to mod x. If x is negative, it becomes positive in case of mod. So that's why what you can write? Finally, Py of y equal to, it is 1 over 9 for y equal to 0. It is 2 over 9 for y equal to 1, 2, 3, 4. 0 otherwise. In this way, we have to find the probability mass function of random variable y, which is a function of x. Okay. So if you draw them properly, how they look like? So this is the two PMFs drawn graphically. Okay. So what is happening? So Px of x is 1 by 9 from where to where? -4, -3, so on, -2, 1, 0, 1, 2, 3, 4. It is 0, 1, 2, 3, 4. Now what happened? At 0, both are same. +1 and -1 combinedly become 1 here because it is a mod operation. No? Next, +2 -2 becomes 2 here. These two are added. Next, +3 -3 are added here. They become 3 here. Okay. Next, +4 -4 are added here. They become 4 here. Okay. So 1 remains as it is. Here 1, here also. At 0, at 0 they remain same. How to get it 1? You add -1 and +1. How to get it 2? You add +2 and -2. How to get it 3? Add this and this. How to get it 4? Add +4 and -4. Okay. Right. So now we'll discuss something important. So that is called expectation or mean of a random variable. Here, expectation of any random variable is defined in terms of its PMF. It is something like this. Expectation of x equal to summation over x into px of x. Okay. Now this is called mean or expectation. Now next is called nth moment, second moment as well as nth moment. What it is called? It is nth moment. How it is defined? Expectation of x power n that equal to summation over x power n px of x. Now please remember this is a PMF. So you just try to understand the formulas carefully. That is mean of a random variable x is defined as expectation of x that is summation over small x into its PMF. So if we ask you nth moment, that is expectation of x power n, that is defined as in the same way summation over x power n and its PMF. Suppose if I ask you second moment, this is nth moment, no? So second moment means n equal to 2, correct? Then what happens? Expectation of x square equal to summation over x square px of x. So please remember these two formulas, these three formulas. These are very, very important. Okay. Now, so let us solve an example. Consider two independent coin tosses, each with probability 3 by 4 head. The probability of head is 3 by 4. And let x be the number of heads obtained. Let x be the number of heads obtained. This is a binomial random variable with parameter n, 2 and p equal to 3 by 4. Its PMF and mean are. Okay, let me find out PMF first. You can find out mean later. Okay, so read the statement properly. We are tossing the coin 2 times. Probability of head is 3 by 4 means probability of tail will be how much? 1 by 4. Next. So x is a binomial random variable. It says number of heads obtained. X is a binomial random variable implies number of heads obtained. Okay. Now, so how many tosses? 2 tosses. That's why n equal to 2. Correct? So let us find its PMF first. Okay. It is a binomial random variable. You just try to understand things properly. Okay. So what is the experiment? 2 tosses of a coin. Otherwise, tossing a coin 2 times. Tossing a biased coin two times. Which means n equal to 2. Which means n equal to 2. So what is the probability of head? It is given in the problem, it is 3 by 4. The probability of tail would be obviously 1 minus 3 by 4, that is 1 by 4. It is a biased coin, not a fair coin. If it is a fair coin, the probability of head would be same as tail, that would be same as 1 by 2. Now, so random variable is defined as number of heads. So first of all, what is sample space? You are tossing coin 2 times. Head, 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 tail, tail, head, tail, tail. Now, what are the possible values of small x? I mean, otherwise, what are the possible values of small x? You think of it. Which? So, how many times you may get head or tail? What are the possible values of x? What are they? They are 0, 1, 2. You may get 0 heads, you may get 1 head, you may get 2 heads. Okay. Now, so let me find PMF. So what they are asking? Probability Px of 0, which means probability that capital X equal to 0. What is the capital X? Actually, number of heads, which means, so number of heads equal to 0. What is that probability? Find out. Okay. So here what we use? We can use binomial random variable. What is that? So let me write here otherwise. So let me write here Px of k equal to Px of x or Px of k. No problem. Sometimes you use x or sometimes you use k. Don't get confused. Small x and k are interchangeable. What is that? NCK P power K Q power n minus K. This is straight away answer. Okay. So here what is the K value given as 0? What is that? So what is Px of 0? Which means K equal to 0. That is 2C0 P power K Q power 2 minus K. Anyway, K equal to 0, that is 2C0 Q power 2. What is 2C0? 1. That is Q square. What is Q square? 1 by 4 into 1 by 4. Q equal to 1 by 4, no? That is 1 by 16. Now, what is Px of 1? K equal to 1. That is 2C1 into P into Q. What is 2C1? 2. 2 into, what is P? 3 by 4 into 1 by 4. Q is 1 by 4. What is Px of 2? That is 2C2 into P square into Q power 0. That finally becomes 2C2 is again 1 P square. That is 3 by 4 into 3 by 4. Correct? Now finally, what is the PMF you got? Px of K equal to, what do you got? Write everything at one place. It is 1 by 16 for K equal to 0. 2 into 3 by 4 into 1 by 4 for K equal to 1. It is 3 by 4 into 3 by 4 for K equal to 2. Obviously 0 otherwise. So this is a PMF of the random variable X. Okay. Now, so to find out the mean, we need PMF. So that's why first thing is you should find out its PMF. Then you can find out mean and second moment. So what is the mean? The next question was, what is the mean? Mean or expectation? Mean or expectation? So that is expectation of X equal to summation over X into Px of X. Please make a note of this. Sometimes I will write small x or small k. Don't get confused. Okay, just a variable. X or k, doesn't matter. Okay. Now what is the values of, let me write X only. So for your understanding, let me write K only here. Okay. Now K small k, Px of K. Okay. Now K varies from where to where? K can be 0 or 1 or 2. Now expand this. 0 into, if K equal to 0, Px of 0 plus K equal to 1 means Px of 1 plus 2 into Px of 2. 2 into Px of 2. What will happen here? This is 0 anyway. Now simply we get Px of 1 plus 2 times Px of 2. What is Px of 1? 2 into 1 by 4 into 3 by 4. You can verify from the PMF plus 2 into what is Px of 2? That is 3 by 4 into 3 by 4. So you solve this, you get 24 by 16. So that would be equal to 3 by 2 or 1.5. So this is the mean or expectation of your random variable x. So this is the mean 3 by 2 or 1.5. What is the, this is the corresponding PMF. Okay. So we stop here. Thank you.